Hello everyone, this video covers the solutions to participation 5 or test 2 review. The first question is asking you to create a graph using the following information. So just do a XYZ plane first. And it tells you that the graph goes from -2, let's say it's -2, all the way to A. So this is as low as you can go and this is as high as you can go. And then it tells you that f of 3 is equals to -4. So you do your own scale, so this point was here. And then it says that the function is increasing between -2 and 1. So remember, increasing means could be something like this up to this point, and then it's decreasing from 1 to 5. So from 1 to 5, this is going to decrease, and then from here it doesn't tell you any more information, so you can technically do whatever you want. However, since this is decreasing, you have to make sure that it goes through this point. So therefore, a possible graph will look like this. It's increasing from -2 to 1. Once it gets to 1, it starts decreasing. It has to pass through this point, and then from here you have many possibilities. So that's one possible graph. Another one could be like this, and then just keep going up to here, or from here do this, and so forth. So that's it for that one. Number 2 is asking you to write the system of equations in this form. Well, here you can tell that A is equals to 2, 1, 1, 1 minus 2, 2. This is 3, 4, -1. X, capital X, is equals to X, Y, Z. And then B is equals to 7, 3A. So notice how it doesn't matter if you use parentheses or you use brackets. That's a personal choice. So in part A, it's just asking you to write it this way. So therefore, another way to rewrite this, it will be like this. This is 2, 1, 1, 1 minus 2, 2, 3, 4, -1. And then here you have X, Y, and Z. And then they should equals to 7, 3, and A, where this is A, this is X, and this is B. That's it. Now in part B is asking you to use Gaussian elimination to solve the problem using matrices. Okay. So you do an augmented matrix. This is 7, 3A. And remember, the goal is to get 0 here, then 0 here, and then 0 here, and then you do back substitution. Okay, so to get 0 in this one, we're going to multiply the first row by 1. So it's going to be row 1 minus 2 row 2, and whatever we get, we're going to put it in row 2. Okay, so you're going to multiply this by 2. This by 1, this by 2. The reason why we choose the 1 and the 2 is because if you multiply this by 1 and this by 2, that will give you 2 and 2, and -2 plus 2, they cancel each other. You could select this to be negative and this positive. It will not change the answer, but let's go with this. Now the first row doesn't change, so that one stays the same. The second one will be 0. Then here you multiply this by 1, this is 1, and then 2 times negative 2 is 4, so 1 plus 4 gives you 5. So you should stop the video and convince yourselves that this is the case. The next one is going to be 1 minus 2 times 2, so it's 1 minus 4, which is negative 3. And then the next one is going to be 7 minus 6, which will give you 1. Again, check that this is what you get. Alright, so we got 0 here. We need to get 0 here next, and then here, and you should do it in that order. Okay, for the third row to be 0, we're going to multiply this by 3 and this by 2. And since they have the same sign, one of them has to be negative. So let's say that this is negative now to row 1 plus 2 row 3. And whatever we get, we put it in row 3. Okay. All right, so the first one should be automatically 0, but just check. Minus 2 times, oh, this should be minus 3, sorry, this is minus 3. So minus 3 times 2 is minus 6, plus 6, it will give you 0. All right, now for the next one, you don't have to do the multiplication in your head, you can do it on the side. So for this one, it's going to be minus 3, and then plus 4 times 2 is 8, so that's equals to 5. So this will give you also 5. Then the next one is going to be minus 3 plus 2, which will give you negative 1. And then the last one is going to be minus 21 plus 8 times 2, which is 16, which is equals to negative 5. All right, so then next you need to get 0 here. And again, notice that the first row doesn't change throughout the whole process. So now the second row is not gonna change. So the only one you need to change is the last one. So the 0 stays there. And since these two are the same, you can just say minus row 2 plus row 3, and whatever you get, put it in row 3. All right, so this should be 0. Why? Because minus 5 plus 5 is 0. And then minus 3 plus 1 is going to give you minus 2. And then minus 1 minus 5 is going to give you minus 6. All right, so once you get the 3 zeros here, you're done with this part. Now, notice that you use this row, or row 1, to get zeros here. And then we use row 2 to get zeros here. And if this was a bigger system, that's how that works. This one gives you zeros all the way here, then this one here, and so forth. Okay? But now this is what we have so far. From here, now we have the 2x plus y plus z is equals to 7. And then you have 5y minus 3z is equals to 1. And then finally, minus 2z is equals to minus 6. So now we're going to use back substitution to solve the problem. So from here, we get that z is equals to 3. If we plug z in here, then we have 5y minus 3 times 3 is equals to 1. Or 5y is equals to 10. Or y is equals to 2. And then finally, from here we have 2x plus 2 plus 3 is equals to 7, or 2x equals to 2, or x equals to 1. So the solution is x equals to 1, y is equals to 2, and z is equals to 3. And that's it. All right, now question number 3. The first part is asking you to do a sum. So the first part you have to do is minus 2d. So now what is minus 2d? That means multiply everything in d by minus 2. So that will give us, you multiply everything by minus 2. It will be minus 2, 6, minus a, 2, 10, minus 6. This is minus 2, minus 2, 12. So that's the first part. And then h, you multiply everything by 4. So it will give you minus a, 4, minus 12. This is 20a, a, 12, minus 20, minus 16, and 8. And then just add it up. So you add this with this, just the corresponding entries. So the first one is minus 10, then 10, then minus 20. This one is 30, 18, 6, minus 22, minus 18, and 20. That's it. Part B is asking you to multiply d times f. However, for this problem, the size of d is 3 by 3, which means 3 rows by 3 columns. And the size of f is 2 by 3. Since these two do not match, that means this is not possible. So not everything in life is possible. You can ask the clippers about that. All right. Anyways, so what about part C? Here you have to do matrix multiplication. The first thing, just like in part B, you should check if you are able to multiply or not. Remember, the size of f is 2 by 3, and the size of d was 3 by 3. Since these two match, then this is okay, and the result is going to be 2 by 3. All right, so here f is equals to 610 minus 423, and d is 1 minus 1 1, then minus 3 4, minus 5 3, 1 negative 6. All right, so the resulting matrix has to be 2 by 3, which means you're going to end with something like this: 2 rows and 3 columns. Now this and this will give you the first one. So this is what I mean. This row times this column, so this is row 1, column 1, it will give you entry 1 1. And this is what I mean. The first one we multiply, so it's going to be 6 times 1 plus 1 times negative 1 plus 0 times 1. So that will give you the first entry. The second one is going to be now this one times this one. So now this will be 6 times negative 3 plus 1 times negative 5 plus 0. And it looks like we're running out of space. All right, I move it a little bit. So the last one should be then 6 times 4 plus 1 times 3, and then again plus 0. So you see the idea, hopefully. All right, so then the next one is going to be this times that. So this will be now negative 4 times 1 plus 2 times negative 1 plus 3 times 1. And then the next one is going to be minus 4 times minus 3 plus 2 times negative 5 and then plus 3 times 1. And then the last one is going to be negative 4. Sorry, I run out of space here, times 4 plus 2 times 3, and then plus 3 times negative 6. And then just simplify. The first one is going to be 6 minus 1, which is 5. The second one is 18 minus 5 is minus 23. The last one is 6 times 4, which is 24, plus 3 is 27. And this one is minus 4 minus 2, that's minus 6, plus 3 is 3. This is 12 minus 10 is 2, plus 3 is 5. And you should check that these numbers are right. And then the last one is minus 16 plus 6, that's 10, minus 10. Minus 18 is minus 28. Again, just check that this is right. And this is the answer. All right, now let's do number 4. We did something like this in participation number 4, but let's do this one more time. And you should definitely check the participation 4 to give you more insights in this problem. Remember that we're using the formula y equals to y0 e to the rt. Okay, and it tells you that the half-life is 1500. So you're going to use the half-life to figure out the value for r, because you don't have the rate. And we did this before, so the half-life means that after some time you will have half of the original amount, and this cancel. Ln of 1/2, which was minus 0.69, is e to the rt. Sorry, is just equals to rt, or t is equals to ln of 1/2 divided by the time. So from here we have that r is equal to minus 0.69 and 315 divided by 15,000, and this is equals to minus 0.0000, 4 zeros, and then 46.2. So therefore the equation we want to solve is the following. The original amount is 1500 grams. So we'll start with 1500 grams, and you want to know how long it's going to take to get to 500 grams. Again, it's just this equation. So if we divide both sides by 1500, we end up with 1/3 is equals to e to the minus 0.000046 to t. So if we take a log on both sides, from here we will end up with ln of 1/3 is equals to negative 0.000046 t. So therefore t is going to be ln of 1/3, or remember ln of 1/3 is just technically minus ln 3, okay, divided by this. And then depending on how many digits you use, that's going to be the accuracy. So this is approximately equals to 23,780 if you round it to the whole number. And again, like I say, in participation 4, you should always check that your answer makes sense. If you start with 1500 milligrams, and it takes 15,000 years to get to half, So in 15,000 years, you should have 750 grams. Now, since 500 is less than that, so it has to take more than 15,000 years. Now, half of 750 is 375. So in 30,000 years, you should have only 375 left. So therefore, this number makes sense because it's between 15,000 and 30,000. All right, question number 5 is by far probably the easiest question. So it's asking you just to give examples, and you can pick whatever you want. So you could say here y is equals to 2x minus 6. The slope is 2. A quadratic equation, then y will be, let's say, x minus 3 squared plus 4. And the vertex is the point 3, 4. A rational equation, you can have r of x is equals to 3x minus 5 divided by x squared plus 3. What's the horizontal asymptote? Is y equals to 0. Why? Because the degree of this one is bigger than the degree of this one is higher than the top. So a logarithmic function. So g of x would be, let's say, log 3 of x plus 5. And what is the base? The base is 3. Here, it actually is asking you to write it in, to use a specific variable. So I guess we can do that. This should be f of x. And this one will be h of x. And this one r of x. And that's it. All right, for question number 6, it's asking you what is the domain. So this is a rational function. You only look to the bottom. So first you set the bottom or the denominator equals to 0. So this will happen when x is equals to 0. And then if you factor, it will be 2 and minus 2. Okay. So therefore the domain, you can say, is all real numbers except for, you can say, x equals to 0, 2, and negative 2. So that's one way. Now the lazy way, which is acceptable, you can just say x cannot be 0, x cannot be 2, and x cannot be negative 2. So this will be the lazy way, but that's perfectly fine. All right, so the x and y intercepts. So first, let's do the y-intercept. Y-intercept means that x is equals to 0. But in this particular case, if you put 0, you have 0 on the bottom, so this doesn't exist. So therefore, for the y-intercepts, which means x equals to 0, then you have none. They don't exist. Okay. Now, for the x-intercepts, that means that y is equals to 0 or the top is equals to 0. So therefore, for the x-intercepts, that means you want 2x cubed minus x squared is equals to 0. You can factor x squared, so this is 2x minus 1. So the answer is 0 and 1/2. But remember, you had to write it in order pairs. So the intercepts are 0, 0, and then 0, 1/2. Notice how we didn't even pay attention, but I just told you that x is not even part of the domain. So therefore, this is not an acceptable answer. So the only y-intercept is 1/2 and 0. This is actually backwards. So when x is 1/2, the whole thing is equals to 0. So this is the only one. 0 doesn't work because 0 is not part of the domain, and you can see that here. Remember, 0, x cannot be 0, x cannot be 2, or -2. So this is the only Y-intercept. Now, the vertical asymptotes, remember, these are related 100% to this. So whatever is not part of the domain, those are the vertical asymptotes. So therefore, the vertical asymptotes are x equals to 0, x equals to 2, and x equals to -2. Now the horizontal asymptotes, since they have the same degree, then you just divide the coefficients of the biggest degree. So therefore here this will be y is equals to 2 over 1, which is just 2. All right, so we also did this question before, question number 7 in the previous participation. So let's start with all the possible solutions. And remember, you have two choices. You can do factoring if it works, or synthetic division. The possible solutions are plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, minus 25, and plus or minus 50. So let's start with, I guess, let's do number 2. Actually, let's do -2 because I already know it's going to work. So remember, this is 1, 2, minus 25, minus 50. For the synthetic division, you just bring this one down. So this will give you -1. 1. 1 minus 2 is 1 times -2 is -2. This gives you 0. 0 times that gives you 0. So this is minus 25. Minus 25 times 2 is minus 50. It's actually positive 50. This is 0. This is what we want. So therefore, that means the x cubed plus 2x squared minus 25x minus 50 can be factored as x plus 2, because one of the solutions is -2, times x squared minus 25. And clearly this is a difference of squares, so this is x minus 5, x plus 5. So the solutions are x is -2, x equals to 5, and x equals to -5. All right, number 9 is talking about earthquake magnitudes, which has to do with logs. Remember, the formula which you can use on the exam is the following. The magnitude is equals to log base 10 of the intensity divided by S, where remember S is always given. In fact, S is equals to 10 to the negative 4. Therefore, since we have two earthquakes that we're trying to compare, you need to find the intensity for each of them, and then you divide each over the other to compare how big is one compared to the other one. Right, so for the first one, for the 8.2, that was the magnitude, so that means 8.2 is equals to log of I1 divided by 10 to the negative 4. So if we change from log to exponent, that means that 10 to the 8.2 will be equals to I1 divided by 10 to the negative 4, which means the I1 is equals to, if you cross multiply, to 10 to the 4.2. So this is the intensity of the first one. If we do the same thing for the second one, which was 5.4, so 5.4 is equals to I1 over 10 to the negative 4. Therefore, from here, we're going to have 10 to the 5.4. is equals to I2, this should be 2, divided by 10 to the negative 4, or the second intensity will be equals to 10 to the 1.4. So this is for the second one. So now the question is, how much bigger was this one than this one? So to do that, you just divide. So you want to have 10 to the 4.2 divided by 10 to the 1.4, and this equals to 10 to the 2.8, which is around 631. Therefore, the 8.2 magnitude earthquake was 630 times more intense than a 5.4. Now this problem looks complicated, but it's actually pretty easy because all you need is the formula, which I will give you this on the formula sheet, or you can write it yourself. This value is always this, so this problem is actually the easiest word problem we have so far, believe it or not. All right, number 9 is also the same kind of question that you saw in participation 4. So remember, this is f of g, which will be 3 x plus 4 over 5x plus 2 q minus x, so that's just x plus 4 over 5x plus 2, and that's it. Just leave it alone. Now the inverse of g, so step 1, we have y is equals to x plus 4 over 5x plus 2. You don't have to do it in steps, but just makes it easier to keep track of what's going on. Step 2, you change x for y, so it will give you y plus 4 over 5y plus 2. And then step 3, you solve for y. So you cross multiply, we will have x times 5y plus 2 is equals to y plus 4, or 5xy plus 2x equals to y plus 4. Then combine the y's. So we do that, we'll have y plus 5x minus 1. And on the other side, we have 4 minus 2x. So therefore, from here, y is equals to 4 minus 2x divided by 5x minus 1. And this will be the inverse function. And that's it. Now remember that g is equals to x plus 4 over 5x plus 2. Therefore, if you want to find the domain, all you have to worry about is to make sure you don't divide by 0. So for the domain, we have 5x plus 2 equals to 0. So that means that 5x equals to negative 2, or x equals to negative 2 over 5. So that means that the domain is x cannot be negative 2 over 5, which is technically the vertical asymptote, if you look at it that way. Or you can do the interval notation, minus infinity to negative 2 over 5, union 2 over 5 to infinity. Now, to find the range, remember we're going to rely on the inverse function. The inverse function was 4 minus 2x divided by 5x minus 1. That's what we found before. The domain for this one is the x cannot be 1/5. So therefore, the range of f is going to be the y cannot be 1/5. You can also say all real numbers except for 1/5, or you can use interval notation and do the same thing we did for the domain, and that's it. Or you can say all real numbers except for y equals to 1/5. And you you can say the same thing for this one, all the real numbers except for x equals to -2/5. So you had three ways to write it: this way, this way, this, or this. Right, for the last problem, we're gonna need the three properties we used before. Remember, log of a times b is log of a plus log of b. Log of a over b is log of a minus log of b. So this is rule 1, rule 2, or property 1, property 2. And then property 3 is that log of a to some k power is equals to k log of a. So we're going to use these rules to simplify this. Alright, so by property number 2, this is the same thing as log of x to the r yt minus log of z to the n. Then by property number 1, this part becomes log of x to the r plus log of y to the t minus log of z to the n. And then by property 3, this is equals to r log of x plus t log of y minus n log of z. All right, finally, by property number 2 first, this is again log of radical x, the cube root of y, minus log of w squared z to the 5th power. Now, recall from elementary algebra or intermediate algebra that if I write this, it means b to the 1 over n. So therefore the square root of b is just b to the 1/2. The cube root of b is b to the 1/3, and so forth. Okay. All right, so if we use that, then this is going to be the same thing as log of x to the 1/2 plus log of y to the 1/3. So this is by property number 1 minus log of w squared plus log of z to the 5th power. Then by property number 3, this is 1/2 log of x plus 1/3 log of y minus, you need to distribute the minus sign, 2 log of w, then minus 5 log of z. And that's it.